Hello everyone, welcome to an Specialist training channel. I am Omar Farouk and today we are going to talk about the alloying elements. So let's start. In the last video, we said that the steel is a combination of iron and carbon. Steel is alloyed with various elements to improve mechanical properties such as the toughness, the hardness, and the tensile strength, and to produce special properties such as resistance to corrosion or heat. There are too many alloying elements. Let's start with the common alloying elements. Number one is the carbon, the most important constituent of steel. It raises tensile strength, hardness, and resistance to wear and abrasions. It lowers ductility, toughness, and machinability. Number two is the chromium. Chromium added to carbon steel in percentages, usually greater than 11%, creates stainless steel. At this percentage and greater, the corrosion resistance of a steel vastly increases, and oxidation of the iron is prevented in many conditions. The iron doesn't oxidize because the chromium will oxidize first and form a protective layer over the steel. Chromium also helps to improve mechanical properties. Even in small amounts, it will increase the steel's strength, hardness, and the ability to be heat treated. Common steels with high amounts of chromium include grade 439, 309, 2205 stainless steel. Number 3 is the molybdenum. Molybdenum, like chromium, has an effect on the corrosion resistance of steel. Molybdenum can also increase the hardenability, toughness, and tensile strength of steel. It increases the hardenability by lowering the required quench rate during the heat treating process to make a strong and hard steel. Molybdenum can also reduce the risk of a pitting in steel as it improves the resistance to chloride-induced corrosion. Common steel grades with high amounts of molybdenum are the A group of tool steels and many stainless steels. Number 4 is the vanadium. Vanadium is used to help control the grain size of the steel, keeping it small. The grain size is kept small because the vanadium carbides that form when vanadium is added to a steel block the formation of the grains. This blockage prevents the grains from growing to be as large as what they would be without the added vanadium. This finer grain structure helps to increase ductility. In some steels, carbides formed by vanadium can increase the hardness and strength of steel. Steel alloyed with high amounts of vanadium include A3, A9, O1, and D2 tool steels. Number 5 is the manganese. Manganese is frequently used in steels to help with the heat treating process. When steels are heated and quenched to increase hardness and strength, the quench must be done at fast rate. The faster this rate, the more unstable the process becomes. Manganese allows hardness and strength to increase the same amount, but at a slower quench rate. This helps to reduce the risk of defects forming during the heating and the quenching process. Steels with high amounts of manganese include A10, A4, and O2 tool steels. 201 stainless steel also has a relatively high amount of manganese. Number 6 is the nickel. Nickel is used to manufacture austenitic stainless steels because it's an austenite promoter. When amounts of chromium around 18% or greater are used and nickel composition is greater than 8%, austenitic stainless steel is created. This combination is extremely corrosion resistant, and austenitic grades are some of the most widely used stainless steels. Nickel is also used to improve the mechanical properties of steels. It's used to increase toughness and impact strength, even at lower temperatures. Steels with high amounts of nickel include all of the austenitic stainless steels. Alloy steels such as 23 and 25 groups also have a high amounts of nickel. Number 7 is the cobalt. Cobalt increases strength and hardness and permits higher quenching temperatures and increases the red hardness of high-speed steel. It also intensifies the individual effect of other major elements in more complex steels. Number 8 is the copper. Copper in significant amounts is detrimental to hot working steels. Copper negatively affects forge welding but doesn't seriously affect arc or oxyacetylene welding. Copper can be detrimental to surface quality, and it's beneficial to atmospheric corrosion resistance when present in amounts exceeding 0.2%. Number 9 is the chromium. Chromium used as stabilizing elements in stainless steels. Each has a high affinity for carbon and forms carbides, which are uniformly dispersed throughout the steel. Thus, localized precipitation of carbides at grain boundaries is prevented. Number 10 is the phosphorus. Phosphorus increases strength and hardness and improves machinability. However, it adds a marked brittleness or cold shortness to steel. Number 11 is the silicon. Silicon is a deoxidizer and degasifier. It increases tensile and yield strength, hardness, forgeability, and magnetic permeability. Number 12 is the sulfur. Sulfur improves machinability in free cutting steels, but without sufficient manganese, it produces brittleness at red heat. It decreases weldability, impact toughness, and ductility. Number 13 is the tantalum. Tantalum element is same as chromium element. It also has a high affinity for carbon and forms carbides. Number 14 is the titanium. Titanium element is same as tantalum element and chromium element. It also has a high affinity for carbon and forms carbides. Number 15 is the tungsten. Tungsten increases strength, wear resistance, hardness, and toughness. Tungsten steels have a superior hot working and a greater cutting efficiency at elevated temperatures. Thank you everyone for watching, and don't forget to subscribe and activate the alarm button to see the next videos.